We'll wait for few more minutes and then we'll start our session. Welcome all of you. So this is our 10th session on the molecular rearrangement and reactive intermediates in the organic synthesis. And today we'll discuss some of the problem based on the week 10 topics covered by the Professor Shantanu Panda in this course. So before going to start the session, does anyone have any doubt? All right. So this is the first question, and in which the question is the major product form in the following reaction. So we have given the compound. If you look at the compound, so this will be the C negative and the Li positive, right? Yeah. So this is the nucleophile, and the another starting material is the epoxide. So on this reaction, so what type of reaction is occur? So there are four options here given. So if you look at the starting, it has the electronegative carbon. So this is the sulfur and R. So which attached to the carbon. So this will be negative, and similar there are other groups. So this C negative, if you look at the structure, so it has the this carbon of the epoxide is the delta positive, and if you look at the mechanism, so this C negative attacks at this epoxide. So ring opening takes place. So this epoxide O will be now it will be negatively charged, and this will be the further attack on the silicon. Then the carbon silicon bond get cleaved from the another carbon ion. So this will be the one for Brook mechanism. So this already covered in the week four, already covered in the week 10 videos. Right. So now the negatively charged form on this carbon, it further attack on the carbonyl. If you look at this carbon, so it has the OTS group. OTS is a kind of good leaving group. So this carbon, when it attack on this carbon, it OTS get eliminated, and this attack addition takes place in the SN2 fashion. So it leads to the formation of five-member rings. So here, if you look at the mechanism, there are three things that we need to notice. The ring opening of this epoxide takes place. So there was two possibility why it attacks takes place on the these A positions, not on the other available positions. This is because uh, this attack, if you look at the group, it is a sterically bulky group, and this addition when this group attack, so it will prefer to attack on the less sterically crowd group, and therefore the attack takes place on the A position compared to the not on the B position. And this was the first point. The second point is once this intermediate is formed, this O negatively charged attack on the silicon, not on the other, not like attack on this OTS or any other position. This can also be possible, but if you look at the attack, it will be a four-member ring, so that's not the possible. So here if it attack on the silicon, so the attack takes place on the five-membered atom. So that's the silicon atom here, and which has the obviously good affinity toward the oxygen, especially the O negative. So this O negative attack on the silicon. So the carbon silicon bond cleaves it from anion. So here once this anion is formed, so this anion then attack on the OTS. So this can also possible that in the reaction, also possible that if you have some second similar molecule which has the such possible own possible position which has the OTS. So the attack can also takes place by the intermolecular fashion. As you can see here, this SN2 attack is on the intramolecular. However, this five-member formation drives the intramolecular fashion preferred over the intermolecular attack, and which leads to the formation of this five-member ring, not the other option, that's the dimer product of these species. So therefore, the option among these option, option D is the correct option here. And if we can also check other option, how we can able to neglect remaining option. So if you look at the option A, so in which you can see they have shown the attack of this C negative, that's the carbon nucleophile on the OTS, and then the OTS group get eliminated. So which leads to the formation of compound A. But if you look at the affinity of this nucleophile and the nature of this OTS and the epoxide ring. So among the OTS and the epoxide ring, the epoxide ring is more electro positive, and therefore the attack on this epoxide ring is preferred over the OTS carbon COTS bond. So therefore, the first attack takes place on the epoxide, not on the OTS bond. So therefore, this product is not the major product. If you look at the second product, so they have stopped the reaction in between. So this product formation takes place only by the attack, the first step only. So if you look at their reaction mechanism, they have shown up to here only, and then further it takes the proton from the either from the solid or the workup. So it leads to the formation of this OH will be he will be remain on this compound, and this will be so SiR3, and this is SR. So this product as they have shown. So but in our reaction, they haven't given any water or any workup or any source of proton. So therefore, this reaction move further instead of stopping at this only after the first attack. So this product is also not product. And the other option they have given. So once in the intermediate, so the intermediate form uh, as seen earlier. So this is R3 intermediate. I will directly draw here the intermediate. So after attack of this O, after the first attack, this negatively charged attack here, and this ring opening takes place. So that O negative, and if it directly attack on the this O negative, if this O negative directly attack on this OTS, it can lead to the formation of the four-member ring. But as we also know that the four-member ring formation, so this will be the O, and since the OTS now eliminated, so this will be the product if reaction go by that mechanism. So this will be SR3, and here SR. But in this also, but if you look at this attack by this OTS, this is the four-member ring formation, and this four-member ring formation is also uh, not feasible compared to the five voting. So therefore, this the reaction doesn't go by this mechanism also. Therefore, the option C is also the incorrect option. So among them, the option D is the correct option as we have already discussed in this mechanism. So after the first step, the O negatively form which attacks on the silicon, and that's by the 1,4 broke mechanism, and then the carbon ion again form on the carbon atom, and that carbon ion attack in the intramolecular fashion. So and intramolecular as well as the SN2 fashion. So this OTS elimination takes place. It gives the formation of the five-member ring, and that's our major product in this reaction. So this was the first question from the today's session. So which involved the uh, epoxide ring opening followed by the 1,4 broke reaction mechanism. So we'll move toward the next question. So in this question, the major product form in the following reaction. So if you look at the starting material, we have given the benzaldehyde. Then this is the, if I just draw this compound. So this will is Si CH2 C double bond O, and there it is the OET. So this is the another starting material. Then we have the cyclohexyl twice N Li. So that's the strong base. So basically this is the base. So this N, and again there is again one cyclohexyl ring, and this nitrogen is negatively charged followed by the lithium counteranion that's positively charged. So that's the strong base, strong non-nucleophilic base. So that's the strong base. And if you look at the structure, so if you look at the starting material, two starting material we have, the A, that's the benzaldehyde, and the B, that's the ester. And this proton from the ester, so one of the proton, I will just split this proton, that's the CH2, and another, there will be obviously another proton. So this proton is prone to get abstract by the base. So this negatively charged base abstract this proton, and it forms the negatively charged at this position. So if you look at the reaction mechanism, so this negatively charged formation takes place at this position, and then uh, I will first show roughly mechanism here, and then we will move to other detailed mechanism. So once this negatively charged form, so I will draw in this same structure only. So we look at here, so there will be the negatively charged here. This negatively charged can now attack on this electrophilic carbonyl carbon of this benzaldehyde. So this negatively charge attack on this benzaldehyde, and this will convert into this pH CO negative, and the proton will be, I will just draw here. Here there is a CH which has the Si, and on the other side there will be OET. And further, if you look at this attack, so this can attack on the silicon, further negative charge formation in the manner of earlier reaction. So if you look at the detailed mechanism, so that's the reagent that I have given the uh, I draw here also. This was the starting material CH2 C double bond O OET, and this base abstract the proton. So this SiMe3, then this OET entire group. Uh, so this entire group represented as C double bond OET, right? And this negatively charged as shown earlier. So this negatively charged form. Now this negative charge attack on this carbon, and it forms the O negative. So this is the part of the benzaldehyde, right? And this is the part of, I'll draw with the green, some different color. This is the part of this entire group. Now this O negatively charged form. So this negatively charged, and always keep remember, so whenever we have the O negative and the Si silicon in the same compound, in the if it is in the at the one position, there will be definitely the this O negative. So this is the somewhat slightly wrong representation. I will just rub this one. So it should be Si Me3, right? So this O negative attacks on this Si, and once this attack on the Si, this it will form the negatively charge on this carbon, and again once this form the bond here, this O again get eliminated. So there will be a concerted reaction mechanism. So I will draw one intermediate, one extra step here. So how that intermediate step looks like. So this will be the O, this will be Si, and this is the hydrogen. So this will be the negative charge here. Once this negatively charge forms, so this negatively charge goes here, and this bond move to here. So this will leads to formation Si double bond O. This compound as a, so you can see this compound will be eliminated here. So minus, and it forms the compound. Now the question is about the geometry, or the why this form in the trans fashion or the E fashion. So that's because if you look at the intermediate step, so this intermediate step, this bond, bond, new bond formation, followed by uh, this bond cleavage takes place in the conservative fashion. So therefore, we get the E as a major product. So if you look at the among the options, so this E product as a major product, that's the product we get in the course of reaction, not this one. So we'll see why selectively the E product formation in some other examples. But as of now, uh, so the ester alpha beta unsaturated ester formation takes place in this reaction. That's the option A is the correct option here. Then we have the another question. So this question based on the major product formed in the following reaction, and if you look at the starting material, which has the here there is a keto group, ester, another keto group. So there are three functional groups here, and Lawson's reagent added on this starting material, and this MW is the microwave irradiation at the 150 watt and for a 6 minutes. So what is the product is formed in this reaction? So first of all, we need to see what is the Lawson's reagent. So I will show here the mechanism for this reaction. So this Lawson's reagent is, so whenever we have any keto group in place of Lawson's reagent, so this keto group convert into the this functional group C double bond S. So that's the key mechanism in this reaction. So we have three equivalent of Lawson's group. So if you look at our starting material, this one keto, the two keto. So the both the keto group convert into the C double bond S group, and the ester group is not reactive towards the Lawson's reagent. So that's again the another point. The first one is the as seen keto convert into the double bond S, and the second is does not show any reaction with this Lawson's reagent. So once the S double bond formation takes place, then the lone pair on this sulfur attacks on the carbon sulfur bond. It leads to the formation of S negative, or which obviously obstruct the proton from the solvent. So it will be the SH. It will form the SH. And if you look at the how much member ring form, one, two, three, four, and the sulfur is the five. This five member ring formation takes place. One of the bond obviously this is the driving force. The cation is formed at this position because this bond will be now the C positive at this position and on the carbon, because this opening of this S double bond, sorry, C double bond S, and in place of the in the same reaction, so these protons from the both the sides, so these protons are the to eliminate this first proton, there is driving force of this cation, so it will form the double bond at this position. So this is the double bond, and another this proton is the acidic proton, so that again get eliminated. So and this will be as a SH, and again another H, that's the H2S elimination. This proton, that's the in place of eliminate as the H plus, and it might be get abstracted in the solvent. So it leads to formation of the fiber ring with the two double bond and the sulfur atom. So this is the product is formed. So in this reaction, the role of lossless reagent is to convert this ketone to S double bond S, and further, uh, as in the reaction, there was two different sulfurs are present. One of the sulfur atom attacks on the center carbonyl center, and which then further gives the ring opening. Now the question is, so why this sulfur is attacked on this on why not the another sulfur? So there was the A and the B, two different sulfur atoms are present, right? C double bond S bonds are present. This can also have the lone pair, and this can also attack on the center. So that's my question. So you can uh, go with the same mechanism, this another mechanism by in which the another sulfur atom has attacked. So right on this one. So instead of the this sulfur, so if another sulfur attack on this position, so what will happen? So if that sulfur is attacked, so this bond get will be like this, and this sulfur will be go here. So what will be the product? So the product will be, so this will be again the fiber ring. So that's the sulfur. So this is the sulfur. Then it has the carbon, which has the CO2Me group, and CH2 pH group. Further, it attacks on this carbonyl carbon, which has the butyl group attached, and this ester there was in between. Sorry. Right. So this is the product. So here also one proton is there and another proton for this carbon also. So if I just give the numbering, so this is the sulfur 1, 2, 3, 4, and the center is 5. So this sulfur 1, 2, 3, 4, and this is the 5. So these are the 5 centers. And in this also, what will happen then next? Next is the obviously in the same manner the proton leads to the formation of uh, this H2S removal, and here also this proton is acidic. So here it was the positive charge because the sulfur has attacked. So this will be eliminated and it will form the double bond. So in both the cases, the products are same. However, if you look at the second mechanism, there is not such driving force to eliminate the proton which attached on the 4 number carbon atom for this proton. So there must need to be such a driving force to for the elimination. So this SH elimination, as in earlier case by the mechanism. So this was earlier mechanism. Let's say here. So this SH elimination takes place in the earlier mechanism. From this proton was from the side of the ester, but here uh, to remove this proton, there is obviously this positive charge at the adjacent carbon. So this proton elimination is much faster, but this proton elimination, so here, so this one is not that much faster. So might be the SH elimination is the driving force to eliminate this proton. But by both the mechanism, the final product is the same. So if you look at the final product after this step, so the final product will be the same. So if you have, if the sulfur attack by whether the sulfur attack or the sulfur attack both give the formation of same product. So among these options. So option D is the correct option here. And we can simply eliminate other options. So if you look at this first option, in which they have shown upon addition of the lozenge reagent, it shows the ester group convert into the C double bond, carbonyl group of the ester, carbonyl of this ester convert into C double bond S. So that's the wrong. Here also same they have shown, and here they have shown only one. But if you look at the losses reagent, we have excess of losses reagent. So therefore, the second keto group can also convert into the C double bond S group. So therefore, the other three options are uh, incorrect. We'll move toward the next question. So in the next question, so what will be the correct order of SN1 solulysis rate of the following compound? So we have given three compounds. So if you look at the three compounds, and we need to identify rate of solulysis. Now, if you look at the structure one by one, so this structure which has the OTS group, and uh, there is no any addition groups, right? And second compound, if you look at the second compound, this Si and OTS. So this Si and OTS, they are seen to each other. Si 3, and the third compound which has the Si 3 and OTS are anti to each other. If you look at the solulysis by SN1 fashion, so we need to draw these compounds in this fashion. So let's say I will draw. So let's say this is the OTS, and this is this, and here this is the SiEt3. So for the solulysis to take place, so elimination of this OTS group or SiEt3 group need to take place to form the carbocation. So if you look at the mechanism in the chair formation step, so this one is the for the first compound A, so which has the uh, once this eliminated, it forms the carbocation, and so that's the simple carbocation. So this will be the secondary carbocation, and depends upon the stability of the secondary carbocation, the stability will order will be followed. Now in the second compound, we have the this OTS. Once this OTS is eliminated, it forms a carbocation. So that's the carbocation. But you need to identify, you need to see these are the Si Et3 and this carbocation they are carbocation they are anti the vacant lobe is anti to each other. And another example here, so this as shown, so this is the Si, and this was the filled orbital, and this is the vacant orbital, right? So once OTS get eliminated, uh, so this Si, the the electrons with this Si, they get pushed into this parallel orbital. So they provide certain stability to this carbocation, and that's the driving force for the uh, elimination by the solulysis faster in this compound. So the compound C has the secondary carbocation. All the three compounds have the carbocations. They are secondary, but in the C compound, so this beta carbocation, the secondary carbocation, and they are beta to silicon. So if you look at this beta, so they are that's the alpha and this is the beta. So beta to silicon and anti-periplanar. So if you look at they are anti-periplanar, and in the another one, so they are, so this is these are the bond pair on the silicon. So this is the bond pair on the silicon, and that's the vacant lobe of this carbocation. So they are not anti-periplanar. So this anti-periplarinity provides some sort of stability. So therefore, order of solutions will be vary in this fashion. This will be the C will be the highest rate of the solution, then the B, then the A. So if you look at the correct answer for this one, so this will be the order. So option B is the correct option here. The next question is based on the so the question itself it mentioned which Lewis acid is commonly used for the following reaction. All right, so we have given the aldehyde, then the 1,3 uh, dithiol in the DCM, and this is basically the aldehyde protection reaction. So this is the product, and so we need to add some sort of Lewis acid to complete this reaction. So whether it is BF3 thread or MgBr2 or scandium triplet or none of the above. So basically we need to add the Lewis acid, and BF3 thread works well. So BF3 thread provides, so this will be the goes in this fashion. So this bond get polarized, and therefore this SH attacks on this carbonyl. So the first reaction goes by this manner. So it will be, if you look at the mechanism, so it will be this O, B, F2 now, and another, sorry, BF3. So this will be the negatively charged now. SH and SH. Then the second molecule of the SH attacks on this position, and it will get eliminated. So we get the product. So which in which there will be a two sulfur like this. And so therefore, if you look at the Lewis acid, so this is the Lewis acid. It works for this one because the MgO bond formation. So MgBr2 is not that much. The Lewis acid property is lower compared to the BF3 thread. Same for the scandium triplet. So this diethion formation is catalyzed by this BF3 trait. So therefore, option A is the correct option here. So I will remove all the options. The next question is on the thiophenol. So we have the thiophenol. The reagent is the NaOH and the sorry the yeah NaOH and 1 equivalent of NaOH. Then we have added here BrCH2C-OMe. Now the question of the selectivity, whether this SH, so on this thiophenol, when you add the base, it will give the formation of S negative. Now here, so in the second molecule, second reactant, we have the bromo, ET, right? That's the ester. Sorry, OMe. We have the two centers. That's the this carbon bromo bond can be eliminated by SN2 fashion or by attack of this. Sorry. So this can be attacked directly on this carbonyl center. and this bond can be eliminated. So PH, CH2, C double bond O, OMe. Whether this can form, or also there is another options. That's the once this S negative uh, is there, so it can be attack on the carbonyl center. So it can attack on the carbonyl center, and then obviously it will go up, then come back, and then the OMe can eliminate it. So it might be the pH double bond O CH2 Br. So this is the another product. So we have given the both this either option A. So that's the obviously wrong option, or option C. Among these two, we need to identify which one is the correct option. So what is the uh, correct product among these two? Whether option A is the correct or option C is correct product. So if you look at the answer for this one, so once this SH form, it attacks on this bromo, and this bromide elimination takes place. So it gives the formation of option A as a product. Sorry, the option C as a product, and not the option A. So this is the question from the selectivity. So which one? So this is question for you. Why not this S negative attack on the carbonyl? So I hope you will find some answer for this one. So we'll take some other questions also. So this was the question that we have solved. They are from the week 10 problems. Sorry, the week 10 topics. Now we'll move toward the some of the questions from the week 11 also. So the first question here is so that's the first question. So if you look at the starting, the given we have the starting, this is the alpha beta unsaturated ketone, but which is again there is extended conjugation of this. So this is again there is again further uh, double bond, which is again in the conjugation to the this alpha beta unsaturated ketone. And here we have given the ylide. So if you look at this CH2 negative from this ylide, so this attacks on the center, which is less sterically crowded. Further, the double bond conjugation is moved in this fashion, and it gives the formation of the one intermediate. So that will be looks like this O negative. The remaining bond will be, I will just draw that one. This is the bond. This was the earlier bond, and now newly formed CH2 S double bond O Me and this Me, right? Now, if you look at this one, this O negative will come back to here. This double bond move to here, and once the double bond move, so this bond, this negative charge through this carbon, sorry, this lone pair. So this was the positive charge, right? So here the positive, it will be remain as it is here. Only the negative charge attack. So it gives the formation of now. So this will be double bond. The double bond will has moved this position. So the this carbon architecture will be the remain same. This was the CH2, and here that was the another that cell the S double bond O, Me group was there, the positive charge. So that bond get eliminated as you can see here, and this CH2, this is the newly formed bond, right? So this is the three-membered ring formation takes place. So, and this entire group eliminated as a S double bond O, sorry, CH3 S double bond O CH3. So that's the Me. You can write that as a CH3 or Me. That's no issue, right? So this is what product we get. So what will be the product in this one? So option D is the correct option here. Now you may ask why this CH2 not attack on this carbonyl or not attack on this double bond of this or at the fourth position. So why it attacks on this sixth position? So the reactivity it reacted toward the less sterically crowded position, and that's the driving force attack of this elide on this one, two, three, four, five, six position. So the CH2 elide attack on the sixth position, and therefore the option D is the correct option here. So if you want to look at the detailed mechanism, so that mechanism also I will just paste here. Uh, so you can write down from this slide. Right. So here is the detailed mechanism. You can refer it from here. The another question that I will take. So in this question, the Swan oxidation of the primary alcohols is carried out at which temperature? So generally the Swan oxidation carried out at the minus temperature. Otherwise, pulmonary reaction can take place. So that's question I don't think need to. So basically in the week 11, most of the question based on the oxidation reaction. So I will take a few of the question from week 11 also. So this is the question. So in Parik during reaction, sorry, oxidation, which reagent is used to activate DMSO? So we have given the list of reagent. That's the DCC, auxiliary chloride, SO3 pyridyl, and or acetic anhydride. So which reagent is used for this one? So for this reaction, SO3 PY reagent is used. So I'll directly put the answer. So if you look at the mechanism of this one, so DMSO activation, that's the CH3, double bond O, CH3, and so this SO3, sorry, here it is. So this double bond goes here, it forms a negative charge, and then it attacks on the SO3 PY. So it gives the formation of O, S, double bond O, double bond O. So that's the part from the SO3, and here it will be now S positive and the PY as a counter anion. So this one is the active uh, species in the uh, this Parik during oxidation. So SO3 pyridyl is the reagent used to activate DMSO. So in sour oxidation also we need to use the auxiliary chloride as a reagent to activate DMSO. So I hope you are aware about the sour oxidation and the mechanism of the sour oxidation. So you can also have a look at the mechanism of the sour oxidation. Then there is a reaction based on the uh, selectivity. So if you have the one of the starting material, let's say this is the question, and what will the major product form in this reaction? So we have the DMF and the POCl3, right? So this DMF POCl3, so it leads to the formation of. So among this one, which position is active? So if you look at this one, this bond goes here, and through this position, the formylation reaction takes place. So I hope you are aware about the formylation reaction. So that's the formylation reaction. And if you want to look at the mechanism, so I will give the mechanism for you. So this is the reaction mechanism. So in this one, so if you look at the DMF, so the POCO3 activate the DMF. So the O negative charge attacks on the phosphorus, and it leads to formation of and the driving force is the lone pair of this nitrogen on of this amide, right? So this lone pair goes in the conjugation with the carbonyl. So O negative attack on the phosphorus, PO, and then it gives the formation of those one chloride is eliminated that further attack on this carbon center. So this is the active species form in this combination of DMF and the POCl3. And when we have the species on which we are doing formulation reaction, so here we have the starting material. So if you look at this starting, this nitrogen lone pair goes in the conjugation and attacks from the C3 position to the this active species, which leads to the formation of the formulation at that position. But if you look at if you have some simple starting, so in that case, the formulation reaction will be takes place at this position. So that's difference you need to identify. This is because in this question, there is not involvement of this the double bond of this benzene ring, but here, so from so this lone pair it moves to here, then it move to here, and it attacks takes place from this carbon on this formyl on the electrophile. So you can refer the detailed mechanism of this formulation reaction from this slide. So I don't think any difficulty you find to understand this mechanism. Only thing is uh, the position on which this formulation reaction takes place. So in the options, they given the formulation on this position, which is incorrect. So option B is the correct option here. And this is the reaction is the Wilsmer-Hike reaction. So if you look at the condition, DMF plus POC3, that's the Wilsmer-Hike reaction for used for the formulation of the aromatic compounds. Then another question, I will take one more question. So which is like on the so if you have the alpha bromo ester and you want to you have so better I will try directly show here. So this is the alpha bromo ester, and you have added the POET thrice. You are aware of phosphorus has the lone pair of electron, and what will be the product in this reaction? So if you look at the electrophilic center, so this is the CBr bond is the bond which is electrophilic, C double bond O, and there is ester. So there are uh, two centers on which the this attack can be feasible. So where the attack takes place. So this attack takes place on this bromo part. Sorry, CBr bond. So this is the mechanism. So once this POET lone pair attack on this CBr bond. So this is the OPOT. This is the entire group. Now this BR eliminated. So that attack on the this eliminated BR attack on this one of the uh, OET group, which leads to formation of P double bond O bond. So this will be the P double bond O and then OET, OET twice. So that's the product form. So this is the compound. Option A is the correct option here. So why not this reaction? Because the OBr negative that has the so this is the O CH2 CH3, that's the OET, right? So the Br negative attacks on this position. It leads to formation of this P double bond bond. So option A is the correct option here. So in this one, they have given direct attack on the cardinal center. That's not possible. So option A is the correct option here. So this was the some of the questions for the today's session. So does anyone have any doubt? So we can clarify that doubt now, or we'll stop here for today.
Hello, sir. Hello.
You're audible.
Sir, audible?
Yeah,
Sir, please explain question number 12, uh,
from the
assignment 10.
assign.
Assignment 10, from assignment 10. For PK
Uh,
value.
yes, I will check the question. So it is on the NPT. Sorry, it's in the from this assignment. Yeah, from this week 10, right?
Ah,
I'm just logging on the portal. So right, I will take that question on the screen. Right. So is this is the question?
yes, sir.
Right. So in this question, if you look at the question itself, so uh, in the all question we have the CH2 group. So this is the SPH. Then this sorry, the CH3 we have all in the all question. So CH3 SPH. In the second molecule also the same S double bond O. Then there is a pH, and the third one also CH3 S double bond O pH. If you look at all the questions, sorry, all the options, the pK values represent acidity. So lower pK,
Lower PK, higher
hi-
acidity.
right? Lower pK is equal to higher uh, acidic, or we can say it more labile proton, right? So if you look at the abstraction of this proton, let's take the example of the uh, third proton. So also it also explain the stability of this conjugate base. So the stable is the conjugate base, more stable is the uh, so that's the pH, right? So once this proton is abstracted, it forms the C negative, and this sulfur double bond O, double bond O, and then there is a pH. So once this negatively charged form upon the abstraction of the proton, so that's the minus proton, right? Minus H plus. So this negatively charged stability of this conjugate base defines
More
the stab
stabilized carbon ion.
right. So here CH2 double bond S double bond O negative, and then there is pH. So this is one possible what we can say, one possible intermediate. So this is the second, this is the second. Another possible is the this shown with these carbon. There is A and B, two type of what you can say, two type of
Type of resonating structure possible.
right. So two type of resonance structure possible. So same case with the uh,
In case 2, one resonating structure possible, and in case 1, no such type of resonating
uh,
structure possible. So
correct.
it may be 3, 2, 1.
Right. The order of acidity. I am saying
Order of
order of
acidity.
3, 2, 1. This is the order of acidity.
Order of acidity. Order of acidity and pK value directly proportional होगा sir.
No, it will be opposite, right? Order of acidity. This is the 3 is stronger acid. Therefore, the pK value for 3 is the lower than 2 than
So
A.
yes, yes, yes.
So it will be opposite. So which option is correct option here? So there will be so sorry, this one,
Yes.
right?
1, 2,
So
3.
so I will just for I will just remove this one. On the next slide, I will draw order of acidity. 3 is a stronger acid than the 2, than the 1, but order of
pK
but but pKa will be
1,
uh,
2, 3.
right. Sorry, 1, 2, 3, 1, 2, and the 3. So that was the concept behind this question. So it might be slightly confusing because we may think the order as we have got confused earlier. But yeah, the option A is the correct option here.
Yes sir, थोड़ा confusion था. Order of acidity और pK वो inversely proportional होगा.
Right, exactly.
ठीक है सर, थैंक यू सर. प्लीज क्वेश्चन नंबर 10 थोड़ा एक्सप्लेन कीजिए.
In the same assignment,
सेम असाइनमेंट.
right. So in the same assignment, I will just take that same question on the screen. I think this is the same question as we have seen today. So generally, I take the similar type of question so it will be helpful for solving assignment question. So I'll
ठीक
take the so this is the question, right? So and
है.
I directly direct you to the one of the question that we have solved here. I think anyway, we'll directly solve the question. So in this question, so if you look at this base, the starting material, so we have this is the one starting, and this is the elide, but inactive form CH3 S double bond O. Then there is another CH3 and another CH3, right? This Me negative means obviously they have drawn somewhat there is incorrection. It should be CH2 negative, right? Instead of writing Me3 negative, it should be CH3 negative, right?
ठीक है सर.
CH3 negative. So they have did slightly mistake here, but I will correct that one. So here it should be CH2 negative.
CH2 नेगेटिव.
Right. Now we have the NH, that's the basic form. So that's okay. So now So this CH negative, we have the here olefin. So I will draw only one benzene ring. So remaining benzene ring we can consider here. Right. So here double bond, and here it will be C double bond O OET, and similarly here also CO OET. Right. So this CH2 negative can now attack on the this carbon center. That's the beta position. So let's consider it in this fashion. So we have the alpha beta unsaturated compound, and we know when we attack the ylide, this is positive and this is negative. It always attack on this position, right?
1 for addition.
One for addition. So this same manner. So this is also alpha beta unsaturated, right? So once it attack here, so I will take on the next slide for the space. Right. So in this one now, so once it attack here, it will form uh, O negative here. If you look at the delocalize this bond, so once this CH2 attack, so this bond delocalization takes place. So this bond goes to here, and this will be O negative now, right? So
Yes.
this is the part of the naphthalene, and this is the CH2 on which this CH2 has attacked, which is part of the ylide CH3 CH3. This positive will be remain as it is, right? So this positive will be remain as it is. Now this was the bond, and here there was double bond formation. This C double bond O OET is again remain same. This O negative and here O ET. Right. So up to here is okay. Now this O negative form, right, at this position. Now again this can go back here and via this carbon atom. So this carbon atom it attack on this one and this get eliminated. So what will it form?
Cyclopropane ring.
Right. So cyclohexane ring formation takes place. So and this C double bond O OET remains same now in the product. And here there is cyclohexane ring formation. So we'll check the options in the question.
Option
So option
A.
option A is the correct option here. Right. So this is the
Sir,
answer for this question.
sir, ये
And
क्या हॉर्नर रूटिंग रिएक्शन क्या?
uh, right, Wittig reaction. Which reaction?
HWE.
Honors Wittig.
हाँ.
HW. For question number, sorry, I'm not.
क्वेश्चन नंबर 10. ये कौन सा नेम रिएक्शन है सर?
Oh, all right. So this is the Wittig. Sorry. This is the ylide, right?
इलाइड.
So
उटिग
ylide
का
addition.
मॉडिफाइड वर्जन होगा.
No, no. Simple ylide reaction with the alpha beta unsaturated compound.
अल्फा बीटा. ठीक
So
है,
if
ठीक.
you just draw this in the general fashion, so it will looks like what it will be. Just neglect the remaining part from this compound. So we have. So I will draw here. Basically, we always see the example of alpha beta in this fashion, right? So we have the impression of this alpha beta. So in the same manner, it can be like this also, right?
लाइक ग्रिग्नार्ड डाइव अटैक होगा.
Right, 1,4 attack always takes place for with
वन
this
फॉर
one
वन फॉर वन फॉर एडिशन.
because soft, it is not that much hard nucleophile, always soft nucleophile, and
ओके.
it shows the 1,4 addition. So this is in the same manner, it can be symmetrical, right? Nearly for the toward the reactivity. So this is alpha. We have the impression of this. So basically, it is like very same Miller. Only thing now, if you just move step by step. So this is the similar manner. And further, the today this question is in this fashion. So this is just I just go step by step. moving from this question to this question, now this is just ester instead of keto. So in this also, as we know, we have the example. Sorry, in this question, what will be from? This is from, right, product. Now in the same manner, in this question, what will be the product form? This O remain as it is. This was just keto. This was now ester, right?
Ah,
And upon reagent will be the same for the reaction. The reagents are the same that I write with the X. So here also with the same reagent combination, it will give this product. Now from this one, so this was from, if we move from this one, now it will be similar manner. What will be the product? So this keto will be remain same. If you just go step by step, it will be so. Uh, the remaining part you will be same. Now the new CH2 group will be here, right?
right.
The cyclopen ring will be here. And in the last question, last here, it is ester. It was diketo. Now it is diester. In this question, in this one, it will be again remain same. This is double bond O, double bond O. It will be ester, right? So it will remain same. And the new CH2 group will be here.
Generated.
And this is the cyclopen ring. So if you look at our question closely, it will be just for confusing this remaining part. If you generalize this remaining part, this remaining part is,
Every part will same.
yeah,
And double bond
uh,
position,
this
methylene group added will be added.
exactly. So if you look at the directly starting the question, so it should be in your mind should be directly this should be the product,
Thank you, sir.
right?
Sir,
So
please.
this same question that we have taken here, I think. So I will just show the, so you can see here this question. So this CH2, this reagent combination you have seen this ylide attack on this carbon. Now here we have the two alpha beta possibility, right? So if
Possibility.
this is, so always terminal attack is preferred with this type of ylides. So if you just neglect this other part, so if we have the only similar part up to here, at that time the product will be like this. But we have extended conjugation, therefore the product is here. So option from this one
Outside,
option.
outside double bond, methylene group will be added and form cyclopropane ring.
Right, right. So here you can, in the mechanism also you can see, uh, here the first step, uh, this CH2 attack. Now this is the part of the ylide. So this entire, and this is the CH2 of this ylide. So this position. Now when this O negative come back, uh, through this carbon atom, it attacks on the CH2 group and it leads to formation of this cyclopen ring. So instead of this question, this one, so if they have drawn in this fashion, that might be the more easy to understand. So this remaining the methyl, so that was will be remain same, but incoming CH2, so this CH2 and this CH2, this will be the easy to understand. So this is the newly attached CH2.
Very clear, sir. Yeah, you described it taking 2, 3 more example, same type of example. Uh,
Right.
clear हो गया पूरा.
Thank you. So I think there was another question that I believe.
Sir,
Anyway, but yeah, any further question?
सर क्वेश्चन नंबर 6 इनाइल एसिटिलीन में सोडामाइड ऐड किया है. मोस्ट एसिडिक क्वेश्चन नंबर 6 है, थोड़ा देख लीजिए.
Right. I will take the same question on the screen. So let's say we have the, right. So this is the question, right?
दिस इज द क्वेश्चन.
Right. So in this question, if you look at the most acidic proton, NaNH2, so obviously this proton will be abstracted and
इनाइल
it leads,
एसिटिलाइड will be formed in
right.
step 1. इनाइल एसिटिलाइड
Right. So this C negative
negative
and Na positive, right? So
positive।
A product
इसमें
is correct.
SN2 टाइप
This product
एडिशन
is
होगा,
correct.
सीएल
And
निकल जाएगा यहाँ से Me3SiCl से।
right. So these are the up
टू
to here is
परसेंट
okay, right? Now we have the silyl chloride, right?
सिलाइल,
Uh,
हाँ।
Si, methyl, and the Cl bond here. So now obviously C negative attacks on this position. This will be eliminated. It will be pH C triple bond
SI
C Si
SiMe3
Na3. Now we have the in the reaction Cl negative.
Cl
Does
negative।
that is it possible to attack the Cl negative? That we need to see. So if the Cl negative attacks on this carbon, so what might be the possibility? So this can go here, but there is no any good leaving group. This is all the CH3 group, right?
हाँ।
So therefore, the reaction doesn't move. Proceed further.
No further possibility to attack in the triple bond position of acetylene।
Exactly. So option A is the correct option here.
करेक्ट ऑप्शन होगा।
Right.
और देख लेने दीजिए। सर क्वेश्चन नंबर 8,
Question number 8. In the question number 8, so there is a, I think this is the same question
सेम
that
क्वेश्चन
we have
यू हैव
seen in the
टेकन।
form of, right. I will show that question. What will be the answer for that one? So I'll not completely solve this question. So, but I hope I mean, I will take you in the position you should be able to get the answer. So if you look at this book, starting material, this is the aldehyde, right? So this is the CH3,
1,3 डाइथाइन है।
right? So 1,3-diethyl in the presence of BF3. So
एल्डिहाइड में
this will
वन
be
डाइथाइन का एडिशन होगा, एक साइक्लिक 3 मेंबर रिंग फॉर्मेशन होगा, उसके बाद ब्यूटाइल लिथियम है, उस वहां से
right.
प्रोटॉन एब्स्ट्रैक्शन होगा, फिर एल्किल हैलाइड है, आयोडीन निकल जाएगा।
So when we add the butyl lithium, as you mentioned correctly, so what will happen? So this proton will be eliminated. It forms the negatively charged here, right? And once this negatively charged form, we have the ethyl iodide. So this negatively charged now attack on this one, iodide will get eliminated and it will form the CH3, CH2, CH3, and here it will be diethyl will be remain as it is, right? So this is the as you mentioned correct option. So which option is the correct?
ए ए
Option A is the correct option, right?
थैंक यू सर, यू डिस्क्राइब टुडेज क्लास वेरी प्रॉपर्ली,
Thank you.
completely understandable। थैंक यू सर सो मच।
Thank you. So we'll stop here for today and we'll meet again I will stop recording. So stop here. We'll meet on the next Tuesday. Thank you.
नेक्स्ट ट्यूसडे। थैंक यू।